In this video, we'll discuss symmetry. Now, one form of symmetry is called translational symmetry, and this is where the pattern is infinitely translated across the entire plane. When we create it, we're only going to be looking at a portion of that entire design. We want to think about to determine, is this pattern going horizontally and vertically? Let me try creating it and see what happens. So if I take this pattern below and ask, does it have translational symmetry? I would want to take it and shift it horizontally and say, yeah, it continues to go horizontally. Now, what if I shift it vertically? Does it translate? And I can see that when I do that, it translates vertically as well. So yes, this pattern would have translational symmetry. With reflection symmetry, at least one line in a plane has to divide the shape or design such that that one side of the shape or design is the mirror image of the other side. That line of symmetry will create the reflection symmetry. And a shape or design can have no lines, it could have one line, or it could have many different lines depending on the shape or design. When we test it, we draw in possible lines of symmetry and then try to fold or mentally fold along the line of symmetry to determine, do the sides mirror each other. So let's look at a couple shapes. Here we have a trapezoid, and it happens to be an isosceles trapezoid. If I try to draw a vertical line of symmetry and then fold it, what I notice is they don't match up. So that would not be a line of symmetry. But if I draw it horizontally through the middle and then fold upward, I would say, oh, they do match up. So this has one line of symmetry. Now, say I have this double arrow. If I look at it horizontally and fold up, I would say, yes, that fits in perfectly. So that's one line of symmetry. Now, what if I look vertically in the middle? And now I fold to the right and say, well, yes, that folds in there as well. So this has two lines of symmetry. Now let's look at this wave shape that we have. If I draw vertically and then I try to fold it to the side, nope, that doesn't look the same. Well, what about if I go horizontally with my line of symmetry and I try to fold downward? No, that didn't fold exactly on it either. So this one would have zero lines of symmetry. With rotational symmetry, the shape or design has that rotational symmetry whenever the image appears identical as the pre-image, whenever it's rotated a very specific angle measure. The key thing to remember is that there's no set rotation measure. It's whatever is based on that given shape to make that work. For example, there may be an image where the shape takes a 60-degree rotational symmetry. So every time it is rotated 60 degrees, it still looks like the exact same shape. So say we want to construct a 90-degree rotational symmetry using this given shape. So I'd want to rotate it 90 degrees, rotate it again another 90 degrees, and rotate it a third time to give me 90 degrees. So now as I rotate the entire design, I'm going to do the colors to help see this, I'm now going to rotate it and say matches up, it matches, and now I'm back to where I started. So this is a form of rotational symmetry with a 90-degree rotation. Now, last one we'll talk about is called the glide reflection symmetry. A glide reflection is when a shape is first reflected and then translated along the line of reflection. So the symmetry version of that is when the shape or design is in the plane and it is infinitely glide reflected. So to test it, we'd want to see if when we reflect it and then translate it, does the pattern continue? Or could we construct it to continue? So let's say we have this pattern and we want to glide reflect it to create that glide reflection symmetry. So I'd want to reflect it and then translate it forward along the line. Now that I've made that specific translation, I want to keep that pattern of reflection, translation, that exact distance over and over again until I continue to make that pattern. So now I'll look and say, okay, what if I shift this? Does it maintain that pattern to keep that symmetry? So I move it, and I can see that it continues to keep that. Reflect, shift, reflect, shift, reflect, shift. Therefore, this would be a form of glide reflection symmetry.